Right, here we are. What a beautiful Friday afternoon. We've got celestial events coming in our future. And I'm wearing black today in honor of Good Friday. But today we're here to talk about, is prompt engineering dead? Also, long live prompt engineering. It's kind of funny how things evolve and change as we are learning how to use these incredible tools that are backed by the brilliance of artificial intelligence. And there was a story that I came across this week, and it was put out by the IEEE. And essentially, the essence of the headline was prompt engineering is dead. Also, long live prompt engineering. And that's what I'm using as the basis for the conversation today, because I think this is a really interesting topic for us to discuss. From the very early days of really getting into the use of these large language models and understanding what we could do, there was a very powerful force of people that were behind this idea of prompt engineering. And I do think that prompt engineering is something that bears our attention. But I think the definition of what we mean when we say prompt engineering is probably going through some changes. I think we need to think about things in a little bit different way today than we have been in the past. This process is always an evolution, and anytime a new model is released, we may have to start over and really redefine what it is to optimize and improve the capability. But diving into this article that the IEEE put out, there's a couple of key quotes that I just want to call out before we get into the bigger portion of the content. Inevitably, we have a headline that gets our attention, and then the article kind of draws out, maybe it's not quite that bad. And I think that has to be a part of our dialogue. We must be continually discussing what it means to be doing prompt engineering. But here we have already out of the gate one of the very first large block quotes provided in the IEEE article. The only real trend may be no trend. What's best for any given model data set or prompting strategy is likely to be specific to the particular combination at hand. And I think this is the world that we live in today, as we are constantly changing the architecture and the construct and the components that sit behind systems that we build with large language models. This is really a recognition that conditions apply. The classic information technology answer has always been, it depends. And if you're not designing and building these systems, this may not be something that really even matters for your day-to-day use of a large language model. But let's dive into this some more before we make that conclusion, because I think there's going to be some useful takeaways for you, regardless of where you are in the continuum, be it all the way at the bottom where you are receiving this capability and doing something useful with it for yourself, for your personal life, for your business purposes, or if you're on the opposite end of the spectrum and you're a technologist who is studying and learning about artificial intelligence and how to build systems and reliable services that leverage artificial intelligence as a part of the overall architecture. These are all part of the discussion today because I find myself in each and every one of those positions. I use AI every day to get my work done and to improve myself. And I'm also writing code and building systems and thinking about how we put these things together to maximize our value generation from the use of modern technology. Now, the first thing that comes out in the article is that we're going to talk about a number of different research pieces. And I have to really give the IEEE team some good adulation here, because not only did they write a good, sound article sharing their thoughts and perspectives, they cross-linked to a number of other publications and resources to help tease out exactly what it was that they used from a source of information in generating the article beyond the interviews and questions that they asked. We've talked about several of these papers over time, and I'm going to go into bigger detail about these papers because I think it's time for us to continue this discussion around prompt engineering. When we talk about what is possible with these tools, we are constantly surprised at the fidelity of information that we're able to get from the models, as well as the complexity that we're able to generate. I mean, if you look back over the last year, I am really blown away by how many things have been created and brought to bear using this concept of both diffusion models and transformer models to build highly complex text and imagery. And of course, today we're talking even more about a tool like Sora, which some are saying is more of a world simulator than a video generator. We're not here to have that discussion today. But again, the visual component to this prompt engineering, putting prompts together, is not to be missed because there's some real value there. I mean, I have a good time generating the background image for this video every week because I like to look at beautiful art. And that's really what it is. I mean, I couldn't do this 2 years ago. This was out of my reach. And, finding stock imagery that met your needs was virtually impossible. This this cutout I took from the article talks about this idea of not only are we able to get really great results out of these engines, but we're able to use prompts to also further enhance the results that we get. And that is a constantly evolving situation. If you look at this imagery tool, this tool that they're showing here, the neuro prompts, takes an input prompt and it sort of up converts it. And we see this behavior with how OpenAI have programmed Dolly. In fact, if you're in ChatGPT and you ask it to generate an image, you're giving it a very simple prompt oftentimes, and it is deriving a much more complex illustration of that idea. So we already have this concept of automated prompts in the tools that we're using today. So I don't want you to get confused and think that when we talk about prompt engineering, we're only talking about human derivation of a useful prompt, because it does go beyond that. But I think the changes that we're seeing is that there is less human prompt engineering, and it's really increasingly moving toward this concept of auto tuning or generation. And, sort of the salacious headline I put in this live video presentation really is around the idea of, if you're making your career based on prompt engineering, that too deserves some consideration, because that discipline isn't simply knowing how to write well. It's going to include some additional discipline that's going to be necessary. And we're going to go into deeper detail about exactly what that means. But, we've called it prompt engineering. And of course, I've been saying for the last several months now that I really think it's natural language programming. And I think that still applies, because in many ways we are taking natural language and we're putting it into a specific form to get a better result from the AI model that we're working with. But we keep continuing to evolve what that looks like. And there are many people that are saying this. And I think this really is the cutting edge of leveraging these tools, because it's not enough to use them. If we're going to use them, we want to be effective in that. So the first paper we're going to talk about is a paper that came out, it was probably last month or even earlier than that. It came across my desk in terms of the first time I encountered it and read about it a few weeks ago. And it was brought up with something very specific in mind. You can look up the paper on Archive. I'll also put a link in the comments below each of the videos. And this is what everybody was talking about when the paper came out. If you're following any of the breaking news in AI, you probably saw this discussion of using language from the movie and TV shows on Star Trek. Actually leveraging some of the concepts in that sci-fi presentation to build the prompt. And this actually is a prompt that came from doing optimization of prompts using the large language models output to evolve the prompt that was presented. And one of the most effective prompts that came out of that research in the paper is this direct quote. This is a prompt that is an output that is leveraged as a part of the system prompt in the use of a large language model. And so this uses the idea of communication with a command center. So command, we need you to plot a course through this turbulence and locate the source of the anomaly. Use all available data and your expertise to guide us through this challenging situation. Now, obviously, this could apply to more than Star Trek, but it is very much akin to language that you might see there. And what's interesting is that the experts that are doing all of the research and the work in prompt and prompt engineering, this is something that nobody would have seen coming. And even the paper says, if you would have put this in front of an expert and said, is this going to get a better output? I think largely the consensus would have been, why would it? There's nothing here that it feels necessary or particularly valuable or distinguished from the prompts that have been performing very well over time. Now, we've been talking about all of the ways that you can leverage prompts in terms of structured prompting and the different methodologies that are presented. And one of the more interesting ways to use these large language models is providing an example of what you want the output to be. And in the same paper, this is provided as a sample answer as a part of the prompt to help the model recognize and put things together in a more performant result. And so it's literally giving it the captain's log statements from Star Trek. Stardate is very clearly Star Trek, right? And it is addressing the situation that was a part of the system prompt. So it's kind of a dual part. There's a system prompt, there's a query, there's an output example that you're putting together to derive this better result. And this is really a discovery that is kind of startling, right? But there's a number of other really interesting tidbits in the paper. And of course, I strongly urge you to go and look up the paper and take a look at it, even if you just thumb through it. But it does have some interesting data points. And I'm going to cover much of the details in that paper here. But some of the key quotes that are really important takeaways. One of the summaries, one of the conjectures made in the paper is that there's no straightforward universal prompt snippet that can optimize any model's performance. And I think this is particularly salient today. We are seeing new models released multiple times a day now. We have new tools that are allowing us to combine different models in totally new ways. One of the more prevailing architectures in large language model capabilities is this mixture of experts, which is really side by side, many different models that are optimized for a particular space being brought together. And as we start to think about all of those combinations, it makes sense that you can't have a single bit of prompt that you could plug into absolutely everything and have it improve the performance of the output. And I think that we need to continue to apply the scientific method. It really does come down to try it and see what happens, but also measure the results. And that's one of the things I really enjoy about these papers. It is taking the very analytical approach to try things out, measure it, repeat it, and get something measurable. Now, the paper begins really pointing out that they really wanted to work with tools like GPT-3.5 or Gemini, but they were really limited in terms of what they were able to do at scale because of the costs that were involved. So they are using the open source models like Llama, like Mistral. And if you have the results here, and if you're looking at this and going, well, what about GPT-3 or GPT-4? That wasn't a part of the paper. And I actually think that them choosing to use Mistral 7B and Llama 2, 13B and 70B. That's the billions of parameters behind each one of those models, because we have multiple models with different sizes that are available. I think these open source models are actually really relevant to understanding the research, because we're going to see these open source models applied in so many different ways. The cost factors involved are dramatically different than a cloud-based provider where you are paying on a token basis. So I really value the research that they've done here and the way that they did it, because not only did they provide all of the prompts that they used, they provided the details around how they ran the experiments so that this result could ultimately be replicated and taken advantage of. Now, there's a lot of numbers on the screen here, and I don't want to belabor this, but really, there are two bits of information that we need to pay attention to here. One is whether or not they use chain of thought, and how they put it up against this concept of positive thinking. And we've talked before about the use of specific language, encouraging the model to stop and think, or how important the result is, or how intelligent or good the model might be. In the case of something like Mistral or Llama, even using language like "you're smarter than ChatGPT," did derive an improved result. That's part of the positive thinking package that's included here. And when we look at the comparison of the positive thinking prompts versus the automatic optimization of the prompts, there's some very interesting results to come out here. Number one, across the board, we didn't have a clear winner. In fact, positive thinking actually did outperform the automatic optimizer in a few cases. We did see very clearly that positive thinking outperformed a prompt that didn't consider that, did not take into account the concept of the positive thinking. So the results are really multiple takeaways from this research that they conducted. But what they did discover is that as the model is smaller, it's really much more difficult to leverage the more advanced concepts. What do I mean? Well, the positive thinking prompts really did outperform the baseline, and you can't apply those results across the board. But as the size of the model changes, you might need to do something different. And one of the first thoughts that I want to put out as a reaction to the paper, that's kind of different from what everyone else is talking about in the IEEE article, is that at its core, a large language model, a foundation model, is using human language. Now, when it takes in that human language, it's trying to derive some meaning from that language, and that gets condensed or compressed into a series of numbers that is ultimately tied to a concept of a series of numbers that allows the model to determine thoughts that are like in nature, regardless of their language. It's trying to extract the semantics of that, and it's done a very good job of that. But I like to talk about some of the interesting things around language. You have languages that literally don't have a way to talk about certain words. And so you have to be more flowery in your language. You have to be more descriptive and use far more words to get to the same meaning. As a student of the Bible, I'm frequently not just looking at the text in the Bible version that I have, but also trying to cross that with the original languages that were used to capture the scripture way back when it was written, because there are meanings that can be extracted from that different language. And as the process evolves, we're seeing that ChatGPT and other large language models are actually extracting meaning from our human language. So we really shouldn't be surprised that specific human language in prompting the model is also really essential to the kind of answer that we're getting. There's no question in my mind that what we put into the prompt really does matter, and we should be thinking about our human interactions, because that's going to come through in the language that it's trained upon. I mean, if you are being derisive to someone in how you're communicating with them, you're likely not going to get the best performance. And my history of research into things like DevOps has also revealed that it's not just getting the work done, it's how we get the work done that matters. We can actually improve a human's performance by bringing in considerations that take into account their mental wellness, how they're approaching work, the way that the work is being done. And so this is a really important takeaway that I wanted to share, because this absolutely will always have an impact, regardless of who is designing the prompt, whether that's machine generated or a human that is taking the time to construct that prompt. It really does matter. And I don't think that we're done discovering what kind of language matters. I definitely think psychology is a huge part of the discipline, and we're going to see the results of a human received psychology be interpolated through the large language model. We also see that there's a big correlation in performance with the prompt. I mean, you cannot deny that spending a few minutes to think about the prompt does get a better single result. And if you're building a system that is highly reliant on minimizing the number of queries or the number of API calls, then you're probably going to get a return on investment day one from doing some basic prompt engineering just by reducing the size of the interactions that are going to take place. But as you get into the practice, that's also going to deviate with how large the prompt has to be. I mean, if you have to write paragraph system prompts, you're going to use a lot more tokens. And that also has to be included in the calculus. So I think that there has to be someone involved that is actively thinking about how we're using prompts, how that's plugging into the system, and how we can continue to improve that practice over time. And one of the observations from the paper that I was alluding to earlier is this concept of manual fine-tuning. When you're leveraging a smaller model, the level of language that it is able to construct is going to limit the optimization that is done in an autonomous way. What they discovered and shared in the paper was that when they were asking Mistral 7B to optimize the prompts, they actually didn't get better results across the board. In fact, in a few cases, the results got worse. And so we can't just assume that handing the model the question to optimize itself is going to work. Now, the paper, full disclosure, did not test using Llama 2 to fine-tune Mistral 7B. That wasn't a part of the exploration that they did. And I think that that's probably going to be a limited value proposition, because you need the model to report on the model. When we talk about the architecture of a large language model, using the various weights and biases to construct the model, we have all of these hidden layers in between where there are numbers and calculuses that are taking place to give us the result. And we really don't fully understand those results. I think as we continue to learn about how we can extract more information from the models, this concept of leveraging the model to inform about the model really does make a lot of sense. And it's very clear from this paper that based on their comparison of Mistral versus Llama, Mistral being the smallest at 7 billion parameters, really showed them that there was limited value in automated prompt generation. And that's an important takeaway for us to consider. As I'm playing with a lot of different models, I tend to be on the much smaller side of things simply because the equipment that I have available sort of mandates that I'm working with the smaller models. And I'm not running anything in the cloud today in terms of what I'm building outside of what is publicly available. And I'm only doing some minor fine tuning on my own. So if we understand that anything larger than 7 billion is going to benefit from some level of automated prompting or prompt improvement, how do we do that? Well, there's a tool out there, a framework, and it is the DSPY framework. And it's something that the Stanford Natural Language Processing Group put together. This is publicly available for anyone to go and begin using. And this DSPY framework is actually intended to do prompt automation. So we have an algorithmic way to optimize the prompts that we are given. And they're really doing it not just as a prompt, but also considering the weights and the optimization that is taking place there. Because behind the scenes, we have to manage a number of different factors. So what they start off discussing in the GitHub README really is this idea of, if you're not using a framework to do the algorithmic optimization, you have to do a number of things that are required. And this is important for us to understand, because if you're working with a smaller model and you are doing manual tweaks, then this is a really good rubric for us to use in how we could be thinking about doing that optimization in a manual way. And the very first one they've listed here is breaking the problem down into steps. That's really true for us as humans as well. I mean, the engineering practices that I've been in from the very beginning of my education in the use of computers was, you can't do it all at once. You have to break the problem down. And that really follows through in how we're using these large language models. Okay, once you've got the problem broken down, and it may take a couple of prompts for you to break a problem down. You may not even know where to start. The cool thing is you can use the LLM to do that. You can also issue the command as a part of the prompt to say, break down the steps. And this is really important because you can do it a number of different ways. There is no specific one way to do this. The essence of breaking the problem down could be instrumented in several different ways across many different prompts. But the important thing is that you break it down into steps. Then once you've taken those steps and been able to separate them, now you can work those in isolation. And in talking with others in the field, I had a great opportunity to work with some other folks that were taking a class on designing applications using large language models. One of the discoveries that was made is that there are limitations in how much optimization you can do in a single prompt. And what the discovery really reveals is that if you are trying to do something very specific, that is part of a systematized process, it actually makes sense to take individual prompts and chain them together so that you can optimize each of the steps and the input and output against each of those steps. That also allows you to tweak the individual steps. So you can do continuous improvement and A/B testing against the steps instead of simply iterating one big, enormous prompt. Step 4 here talks about using synthetic examples to tune the steps. Obviously, there is all sorts of programs and opportunities for us to leverage testing and to incorporate that in how we're using the model. If you're fine tuning, there's a whole bunch of process around that. But I think we need to have good examples that allow us to validate if the results are actually improved or not. And then once you've taken those pieces, it does make a lot of sense to take smaller, more purpose-built language models to reduce the cost of that implementation. And what we're seeing is some very unique combinations to really optimize the cost, even in the cloud. When I have been keeping a close eye on Claude 3, and listen, I've been using Claude 3 almost exclusively for the last couple of weeks since it came out. I really love Opus. But what's come across my information input this week is that you shouldn't discount the value of Sonnet and Haiku. That's the other two models that were put out as a part of Claude 3, because they have a dramatically different cost equation. And there are things that you can do to improve the quality of the outputs for those other two models. Not only that, but the other two models, if you go back and watch the Claude video or go hit the Anthropic Claude website to see the benchmarks that they shared, there were a few cases where a model like Sonnet actually outperformed some of the best models that are out there from a benchmark standpoint. So don't assume that the largest, most expensive, most time-consuming model is going to give you the best results across the board. it is necessary to do some fine tuning and searching to try different outputs with different models. And this is going to become a part of the regimented process that needs to be leveraged for building applications and services on top of these models. Now, I will also tell you that I probably pay more than I should for AI services because I am using across the board ChatGPT, Gemini 1.5, and Claude. And in some cases, I'm doing exactly the same input across multiple different models using some plugins from my browser so I can save time and get different results. Having tools like leveraging Perplexity's lab where I can have them run the model, I can get a much faster result and actually see the output that is coming out from the model. A lot of times I'm using the outputs to learn as much as I am in creating some sort of product that would be a derivation of the output. But comparing and contrasting the outputs across different models is something that you should be thinking about doing if you're working with these in any kind of regimented way. And if you're an individual, you know, sometimes you're going to get a strange result. I had I got my haircut earlier today, and I was talking about the AI things with my barber, and the discussion ultimately led to a chat around biology and, you know, is it going to be possible for humans to live much longer? And I'm a big fan of the work that Ray Kurzweil has done, and he was at South by Southwest a couple of weeks ago talking about his new book that he's coming out. But Ray Kurzweil believes he can live as long as he wants to, if he can live another 20 years. And in that conversation, the gentleman that's my barber shared that he had read an article or something in a magazine back in the 1980s, that there was a guy predicting that the first person to live 5,000 years was already alive. But he didn't remember the gentleman's name. So inevitably, I pull out Perplexity and I look it up because I'm curious. I'm like, well, what's he talking about? Well, the result I got from Perplexity from Claude 3, the highest model of Claude 3, couldn't find an answer. It didn't give me a name of the person. I went over to Google and did a Google search, which has the Gemini experiment built into the search results, and it did find it. So even well-written questions that are very clear in your intent come back 180 degrees from each other in the results that you get. So I think it's time that we begin to think about how do we not just rely on a single tool, but use it across the board. And my own personal experiences in doing a little bit of application development is don't underestimate the power of a model that gives you a quick result. But let's go back to DSPY as a framework. They enumerate all of these things from a pipeline perspective because this is the core capability that they're bringing forward with DSPY. So what exactly does DSPY do? Well, it allows you to actually take and break down the steps that are connected to your use of the large language model. You're able to separate on a parameter level modularly the parameters, the weights of each of the steps, and it's built into the framework. And then it allows you to introduce this concept of an optimizer, which is the, algorithmic tuning or improvement of the prompts. So you can plug this in and have it evolve and rate the prompt on a metric in order to maximize the variable that you're looking for in creating better prompts. Because what may be a better prompt to you is not to someone else. That may be highly dependent upon the metrics that are used to determine that. So the automation that they're using really goes across a couple of different places. That they're giving you examples of, look, if you're doing chain of thought, if you're using React, if there are other modules that you want to use, you can take the prompting out of that and optimize the prompt independent of those steps. And really, I look back at what I learned from DevOps, and building these regimented components that can be independently tested and integrated over time is really the key to making the best possible system. You're basically limiting the blast radius of anything that goes wrong and you're also providing a platform that lets you do A/B testing. And, depending on how important the task is at hand, this may or may not be something that's valuable for you to do. What do I mean? Well, I think when we talk about regimented processes, something like a DSPY, where you're working on a very large scale, or where you're looking on critical time dependent results, or you're looking at an extensive step by step process that is integrated into other processes and flows, then something like a DSPY is really valuable because you're able to put that in its place from a systems design and architecture standpoint. But for many of you, that may not be relevant, right? Because you're not an NLP researcher. You're not working on AI. You're not building models. You're not training models. You're not even building applications. And in many cases, you're not even building your own automations. You may just be an average Joe that's using these services. Is DSPY for you? Absolutely not. I don't think for many people that this is something that's necessary. But if you are doing this kind of work, and I think that we are going to increasingly see automation practitioners, because we now have low code and no code solutions where people that have never done information technology things in the past are leveraging these tools. And if you can put in place a regimented process that will allow you to optimize without having to be a genius, without having to go and learn everything there is to know about large language models, then putting in a process that optimizes for your outcomes absolutely does make sense and is probably worth your time. If you're an application developer, does this matter? Well, I think your mileage is going to vary on how you're using it and how it's integrated. It really is surprising how much a simple prompt can do, and it may not be essential for what you're doing. For most of my usage of large language models in doing the things that I do, like writing social media, creating presentations, having conversations, and writing curriculum, oftentimes I'm trying to learn something well enough that I can teach it. And that is not necessarily prompt optimizable, because I just go wherever I need to understand the concepts and the pieces that come together. So I'll be honest, I have not yet spent any significant amount of time with DSPY. Now, I've looked into it so I can understand what it is and where I could apply it, but I'm not at a point where this is something that's necessary for me. I am very interested in it, and I spent time learning more about it this week because I can see this is coming, and it's something that I'll need to do in the future. But what do we do about everybody else? Because if prompt engineering is dead, or it's now going to be the automator's domain and it's going to self-optimize, what do we do? Well, the practical man on the street advice is simply to do some basic optimizations if it's something you're doing all the time. You can ask the model to devise an optimal prompt by giving it a characterization of the problem you're trying to solve, giving it your best example, and asking it to improve on those results. And one of the ways that you can do that is using the OPRO framework. Now, there was a DeepMind paper that came out. I think this was all the way back in June or July. I remember one of my earlier videos talking about the mistakes framework was incorporating this in the discussion. And I extracted this simple diagram from the paper that DeepMind put together, where you're actually optimizing against a score. You're doing some generations. You're sending that information through the LLM and observing whether or not you're getting a better result. And this is something anybody can do. And you probably don't need to individually score it to a high level of detail. But if you need something that is less than DSPY, but more than just taking a stab at it, looking at the OPRO framework, the optimization by prompting, is probably something that's worth your time. I've talked about that in a previous discussion. So feel free to go out there and find that paper. That also is on archive, and I'll put that in the notes. But again, I extracted from these lessons what you could do to kind of ask the LLM to do the optimization. Now, the very first paper covered lots of different ways of doing the optimization, but they were focused on their own matrix of different ways to present the problem. What's different about the OPRO framework paper is that they created prompts that basically said, hey, we're keeping score. Can you do better? And in the prompt, it's actually saying, generate an instruction that's different from all of the other instructions that are here so that it can perform better. So you're asking it to work on the problem you've already given, but instead of working the problem and giving an answer, what kind of improvements can we make to the way that we're prompting it that will lead to a better result? And again, this is based on working with the model that you want to optimize for. This isn't a cross model build out. And I think that there's probably limited utility there, but haven't seen a paper on that yet. Who knows? Maybe that will come out. Beyond doing the OPRO framework to optimize the way that you're submitting your requests, the most important thing that you can take away is to do context. And this applies to the way that we work as humans. When you're having a conversation with a colleague or a friend at a party, if you change the subject out of the blue and you don't give them any indication that you're changing the subject, you might get a funny look or a strange response, because as humans, when we communicate, there is built-in context. And we use that to determine how we're going to respond. The large language model works exactly the same way. The more context you give it for what you're looking for, the better your result is going to be. And for most of us, that's probably all the prompt optimization that you need. If you put all of the context in a single prompt, you're going to get a better result than if you just ask it a dumb question. And, how many times have I gone to Wikipedia to look something up and I hit the page that is, well, which one of these things did you actually mean? Because the same word ties to half a dozen articles. That's the contextual thing that we must give to the large language model to get the better result. The second part is, do not underestimate the fact that all of these models are, to a significant extent, implemented as chatbots. And what that means is you need to have a conversation. Don't take the first answer. In fact, if the thing that you're working on right now is a one-time thing, absolutely don't try to optimize the prompt, because you're just going to waste a bunch of time on something that's not going to matter. You can often get much better results by trying with a good first prompt and then fine-tuning what it is that you're looking for by continuing the conversation. You can consolidate those outputs if you're planning on using it again later, but most often the results of a continued discussion with added context or a question and answer, or ending the prompt with what else do you need to know, can really make a dramatic difference in the results that you're getting. Oftentimes when you're diving into a subject because you don't know what you don't know, prompting the model to give you some guidance or ask some probing questions or add to the context in terms of what it knows is context relevant really does make a tremendous difference. And if you're not running that query ever again, then optimizing it just doesn't make sense. So my advice as we leave this discussion about, is prompt engineering dead? Well, I don't think it's dead. I think it's changing. I think it's becoming more automated. The times that we will choose to do that with a human are becoming fewer and farther between. And there are absolutely places where we should be using the optimization to improve the prompting on things that we're running thousands of times. And if you're optimizing for cost, you may want to go a level further and actually build a model that is a model of the responses, or even just a caching of the responses, so that you can perform better results. But what I have discovered in my use of these tools over the last year and time is that the best outcomes for me have been when I've optimized to learn so that I can better understand what it is. Because often I'm not able to create a single prompt that tells me everything I need to know in a single session. But if I continue the conversation and my goal is for me to get it straight up here, because this is a large language model of its own, right? I mean, all of these systems are built based on what we've learned about the human brain. But let's just be honest, right? I mean, If you saw what came out of NVIDIA's GTC last week, you know these systems use an incredible amount of power to generate the results. Nothing is as efficient as the human brain. And so if you can train your brain to learn using these tools, that is absolutely the better outcome, because this thing is always with you. Don't underestimate the value of education simply because you can put a prompt into a machine and you feel like it does a better job of answering it than you would. Use that to your advantage. This is a learning tool like nothing else. And I think for me, it is the number one use case, because you can never regret having learned something. So optimize for your learning, not building the perfect prompt. So with that, I'd love to open it up for questions. If any of you are finding this insightful or interesting, let me hear from you. I'm really enjoying putting together this content. Love having these discussions. I've got major changes coming up for me. I've got a new job I'm picking up here next week. I start on April 1st. So I'm adding to the things that I'm working on, still very much focused on AI and trying to create value for you in learning about AI. I'm sharing the things that I'm coming across. I have a great time learning about these things. And I really enjoy having the conversation with you. Let me hear from you. If you've got questions, if you're enjoying the content, give us a like, share it with other people, because I'm here to help others learn. That's the goal here. If you're learning something, it's worth your time. And I hope you're having a great week. Go enjoy Easter. I'm going to go do Good Friday service at church tonight. Going to be a great time singing with the choir. I enjoy what I do. Go enjoy life and go make some AI mistakes. We'll see you next time.